Hi, everyone. So today I'm going to be talking about 2-3 trees and the background behind them. So let's get started. So what's the motivation behind creating a 2-3 tree? Well, recall that BSTs can get spindly and as a result, resemble a linked list. And when this happens, we lose the balance structure that we desire. So the goal behind creating a 2-3 tree is to build a tree that always maintains a balanced structure. All right. Let's go over some 2-3 tree characteristics. The first characteristic is that all leaf nodes always have the same distance from the root. And when we say distance, we mean the number of branches. So as an example, let's consider this leaf node here that has 1. The distance between the root to this leaf node is 2 because there are 2 branches from the root to this leaf. And that's going to be true for all leaf nodes in this tree. The second characteristic of a 2-3 tree is that every node always has 1 or 2 values in them. Next characteristic is that nodes with 2 values always have 3 or 0 children. So in this case, in our tree, we have 3 nodes that have 2 values in them, right? This node here has 3 children, and so does this node, but this node here has 0 children. And the next characteristic is kind of in a similar vein as the other one. So nodes with 1 value always have 2 or 0 children. We can see here that these nodes here have 2 children, whereas these leaf nodes here have 0 children. All right, so the last characteristic is a property that is very similar to the properties of a BST. So given a node, the left children are always going to be smaller than their parents. The right children are always going to be greater than the parents. And if applicable, the middle children are going to be between the smaller and larger parent. So this is similar to what we saw in a BST. The left child of a BST was going to be smaller than the parent. The right child of a BST was going to be greater than the parent. But in this case, because a node can have 2 elements in them, there can be a middle child, and the middle child is going to be between the smaller and larger parent. Okay, so let's go into 2-3 tree insertion. So when you insert into a 2-3 tree, you always insert a value by starting from the root and then going down until you reached a leaf node. And when an insertion results in 3 values in a node, we're going to push the middle value up and split the left and right values into separate nodes. All right, so let's look at an example. Let's consider the tree that we saw in the previous slide. And let's say we want to insert 12 into this tree. Well, 12 is greater than 7, but smaller than 14. So we're going to look in the middle child. And when we look in the middle child, in this case, it's going to be 10. We see that 12 is larger than 10. So we're going to go to 10's right child. When we go to 10's right child, we see that this node here has no children. So we're going to insert 12 into this node. And because 12 is larger than 11, but smaller than 13, we're going to put 12 in between 11 and 13. Okay. Okay, cool. So that's going to result in this node here. But notice here that this node 11, 12, 13 has a size of 3. And this breaks one of the characteristics that I talked about earlier, where a node can only have 1 or 2 values in them. So what we're going to do is we're going to push the middle value up. In this case, it's 12. And we're going to merge it with the parent. What are we going to do with the 11 and 13? Well, we're going to split them into separate nodes. So it's going to look something like this. And the last kind of subtle check that we had to do is we need to check to see if the node that we pushed into now has a size of 3. Because if it has a size of 3, we're going to have to do this recursively until we've pushed a node. We've pushed an element into a node, and that node only has 1 or 2 values as a result. Okay, so that's going to conclude this background behind 2-3 trees. In the next recording, I'm going to go over the questions in the worksheet.